will describe the second part of the presentation. I'm not the same GP than the one that was in the tomato story from early on, but still involved in that project, and from a perspective where ThingWorx was also involved. But a couple points that I would say I share with the tomato story we've just heard. First, IoT is a team sport. So there's a couple things that we need to put together in order to really bring the business value that you can derive from IoT. And then second, absolutely agree that with IoT, actually now we have an opportunity to start small. And especially when it comes to making some of your most important critical assets and equipments and things data-driven and more performant, which are the equipment and the asset in your factory. So the approach we're going to describe here, Paul and I, is about a way to improve manufacturing operations in such a way that we can stop thinking about the need to rip and replace before we can gain operational improvement, and rather wrap and extend, so extending the value that we can gain from existing assets and existing capital investment in the factory. So from a smart machines or connected machines perspective at PTC, and especially with our platform ThingWorx, we have manufacturers and all sorts of companies leveraging it to make tomatoes connected, to make cities connected, to make devices in hospital connected. But from this presentation here, what I'm going to focus on are the use cases and the approach where we make, again, equipment and assets in the factory connected. So existing assets, existing equipment in a brownfield environment. PTC, we're also based in Boston. I'm personally based out of Montreal, so I was the Montreal-based guy that they were referring to. PTC itself is headquartered in Boston. We have a second headquarters in Shanghai. For the last 30 years, we've been focusing on one thing, which is helping manufacturers transform the way they design, the way they manufacture, and the way they service products. So back in the days, it means enabling you to embrace and adopt 3D modeling, PLM, embedded software into your design. And when we saw the IoT coming up a couple years ago, what we saw was just the next opportunity to further help our manufacturing customers to transform design, manufacturing, and service. So from a design perspective, connecting to your machine means basically getting very detailed product usage data. Just think of CRM upside down. Instead of calling your customers and asking them, how are you using the product? Now you're calling the products and asking the products, how are the customers and the user really using yourself, which has tremendous value from a product management perspective, marketing perspective, and so on. From a service perspective, the use case are pretty obvious, or the low-hanging fruit are about remote monitoring and remote servicing, where our customers are reducing their service costs by as much as 20%. Bottom line, because once they connect to their devices remotely, then as much as 20% of the service calls no longer required to send a technician on site. They can remotely troubleshoot, remotely figure the problem, and if there's a need to send a technician, at least the technician shows up with the right parts and the right diagnostic. From a manufacturing perspective, we also have customers using our technology, one of them being GE, and I'll let Paul describe what they're doing at GE, but what I'll describe here is the general approach, how we apply IoT to manufacturing operations. A lot has been written and said about IoT. If you look into analyst reports, you'll find a lot of numbers. My goal here is not to take you through these numbers, but this one I really like. This report is from McKinsey Global Institute, and it's actually a reminder that we're doing IoT for one specific reason. We're looking for business value with IoT. And what McKinsey did here is an analysis of where will IoT generate business value. So they've looked at different environments where you could apply IoT. They call these settings. The exact word doesn't matter really, just like you could call it IoT, IIoT, Internet of Things, Industrial Internet of Things, Industry 4.0, however you call it. The takeaway here is that when you look at the real business value, real concrete business value, reduce cost, improve revenue, reduce service calls, improve operational performance, improve quality, what McKinsey found is that the single largest area where IoT will deliver business value is actually on the factory shop floor in manufacturing operations. From a PTC ThingWorx perspective, we cover most of these markets, but we agree with McKinsey that when it comes to real business value, it's actually in what they call the manufacturing settings or manufacturing operations where real business value will be generated. So why do we need IoT? Why is it so difficult to improve manufacturing operations? Manufacturing excellence or operational excellence is a journey. I've been in manufacturing for 15 years. A lot of you in the room probably been for a number of years in manufacturing. We've always been involved into improving manufacturing operations, but manufacturing operations is not an easy environment. Contrary to the tomato story we've just heard where we have one product, one process, and a lot of people involved in the supply chain, still it's a simple product. There is a self-contained product that we can work with. When it comes to manufacturing operations, reality is that even for manufacturing companies that are different factories producing the same product, so if you have factories that are local to your market, one in Asia, one in Europe, one in North America producing the same widget, reality is that you might have one common ERP, a corporate ERP. You might have one common supply chain tool. You might be on a journey to one PLM. But when it comes to the factory shop floor, you'll have different equipment coming from different vendors. You'll have homegrown system for quality, for scheduling, for planning. You might have an MES, but even if you have one, it's going to be deployed slightly differently from plant to plant. And not talking about the variations you'll have from processes to processes. So in manufacturing, it means a lot of different data sources to manage, and typically, historically, a lot of different protocols that the different vendors are using. And then the manufacturing environment is a changing environment also, so we're always challenged with introducing or absorbing new products variants from manufacturing, and then adopting new technology. And last but not least here, in manufacturing, we've been trying for many years to standardize the way we run operations, which is exactly what we need to do. Manufacturing is about repeatability, scalability, but like we've shown, we believe that there's a different way to go after operational improvement in the factory. There's a different way now than rip and replace. And I'll talk to this, and actually I'm using a quote from Paul that he's typically saying in front of our customers, joint customers, where with IoT now in the shop floor, we can stop thinking about rip and replacing equipment and system in order to get to the next operational improvement. We can actually wrap around what we have and extend and gain more operational performance from the existing investment and the existing assets. So from a PTC perspective, what's the platform and software we've built for manufacturing operations? Over the last 2 years and a half, we've been doing a couple acquisitions combined with organic development. And in the platform itself, or in the complete solution, then we've added ThingWorx, which is the market leader IoT purpose-built platform to build specific applications for the Internet of Things world. So it's an application enablement environment that allow you to mash up time series data from business systems and deliver it in a role-specific, very specific application for the user. We've added to it Exida for secured remote connectivity, remote service, and device cloud. We've added recently also to the platform and the software solution Kepware. And Kepware is really the market leader when it comes to industrial connectivity. So basically, if you have a shop floor with equipment coming from different vendors, whether it's ABB, Rockwell, GE, Schneider, Siemens, Rockwell, Kepware has the drivers to connect directly to these different controls and different machines to unlock the machine data and bring it and make it available into ThingWorx. We've added to it CodeLight for machine learning, where, if I would summarize, the goal with CodeLight is to take the data scientists out of the bottleneck in machine learning and predictive analytics. So instead, yes, we all need that big data, or from a manufacturing perspective, maybe all these island of small data and bring them together to have a big data set. The challenge is not getting the data. The challenge is making some sense out of it. So where the CodeLight approach is different is that it will basically run 150, 200 different predictive models on the data. We'll combine them, and will help you find the best predictive model that applies to your exact data. Again, to remove the need or to minimize the need for these data scientists, which are a scarce resource these days. And then from a delivery perspective, ThingWorx and the entire platform by design is mobile, is social, but then we've added Vuforia also to bring you the option to deliver some of these capabilities from a augmented reality perspective, whether it's pointing at equipment with an iPad and having directly the KPIs overlaid on top of the equipment, or whether it's about delivering work instructions to hands-on operators who need their hands-free and want to have some of the information directly in wearable. So from a manufacturing perspective, what that means is, first, couple takeaways here. One, it's not about replacing anything in your factory. It's not about replacing ERP. It's not about replacing equipment. It's not about buying new equipment or replacing MES. What it's about is, let's connect to everything you have in the shop floor. Let's make those existing brownfield equipment connected so we can extract the data from the machine. Let's connect to the rest of the manufacturing landscape. And if you think of a ISO 95 stack, whether it's sensors, MES, ERP, PLCs, supply chain, PLM, we can connect to all of these without replacing these layers. They're there for a reason. But what IoT brings here from a manufacturing operation perspective, it's a layer of flexibility on top of your existing landscape so you can gain additional interoperability, so you can gain more flexibility, and you can close those white space and deliver to the right people, whether it's the operator, supervisor, quality, or maintenance people, the right combined information from different sources they need in order to run their job more efficiently. We do this for a lot of different manufacturers. One example is Airbus here. They talked to the LiveWorx conference last June. In their case, their IoT journey and their IoT journey project on the shop floor is about making the assembly worker more efficient. So they were describing in their presentation that, believe it or not, when they look at the work of an assembly worker today on an assembly line, it's very similar to how they used to work 30, 40, 50 years ago. We have those ERPs, we have those quality systems, those smart tools, but at the end of the day, when you look at how the operator is working, he needs to log into 3 different screens, he has 2 piles of paper, and the work is not really efficient. So what they're doing is using a platform that can connect to smart tools, ERPs, PLM, equipment, and deliver the right information to the worker so you can make sure that they know exactly what's the option they're supposed to install and assemble. The system can error-proof the execution of the process. Since it knows what is supposed to be done, it can validate that the assembly worker is performing the right job. It connects to smart tools, so it can download automatically the right calibration program. It can validate that the right force feedback is coming from the tool to make sure that the right operation and the right torque is being, or the right force in this case in the rivet, is being applied, all with the goal of making the operator more performant, less error, reducing lead time, and improving quality, but by connecting, again, to existing systems and existing tools. So adding this additional layer, IoT layer, on top of all their manufacturing assets. Another customer using this approach to improve their manufacturing operations is GE. And I'll let directly Paul describe what they're doing at GE. And GE is actually both a customer of PTC and a strategic partner. So what we've done actually with GE, we are co-developing it with GE, we are co-marketing it and co-supporting it. So it's not only about enabling the brilliant factory at GE, it's also about accelerating the availability of those small apps to help you start smaller to all other manufacturers out there.
Thanks, JP. All right. So I'm going to take a couple minutes and talk about the effort that we've gone through at GE and how we've brought these tools together to drive the process, right? So part of what this discussion is about is IoT, IIoT-enabled machines. So let me give you a couple distinctions. First of all, manufacturing and operations is my background. A couple weeks out of high school, I started for GM as a co-op student, spent a lot of years in manufacturing, moved into technology, pure technology, and then kind of found my way eventually to a large enterprise software company that I left about 1.5 years ago to join GE. And I wasn't looking at the time to leave because this concept of the industrial internet and driving operations kind of gnaws at me, just something I tend to think about a lot. And a couple of people asked me the question. I said, look, I thought SAP was in a position and the enterprise guys are in a position to solve this, and I thought GE's in a position to solve this. And what really kind of flipped the switch for me was there's a very distinct difference about going to sleep every night, waking up every morning, and waking up sometimes at 3 in the morning thinking about what you need to ship today to fulfill a process. So who in here is manufacturing? Working for manufacturing, has manufacturing assets? Who in here from manufacturing thinks that folks in technology who've never lived and breathed and worked in a plant understand what that's all about? There's a couple. So they're being nice to the IT folks, and they're probably IT folks that spend a lot of time in a plant and absorbed that vibe. But the reality is we're coming at it from a different approach. So when you think about IoT and IIoT, they're two different things. Big data and insanely big data are two different things, right? When I see use cases about the amount of data on the number of cups of coffee that were consumed from Starbucks in New York City this morning, that's, I think, sometimes I'll actually do the math, but I think that's about the same as the amount of data we get off a pair of engines before the wheels come up under the plane, right? There is a significant difference. There's a significant difference around security and the security requirements. There's a significant difference around the outcome, right? When you're building things like jet engines and turbines where catastrophic failure is always a possibility, there's a different level at which you have to deliver the applications into that market. So I think we think about it differently from a lot of perspectives. And that's what really drives the concepts that we put into the plants, how we're looking at the ecosystem. It is a better together strategy, right? You pull the teams together to deliver this. And it was kind of interesting. The whole tomato analogy to me is directly related to a plant. It's like my grandmother's chili, right? She made the best chili. My dad had a corner tavern in Northeast Pennsylvania, and people would want to know, like, what's the recipe? And she could never tell you the recipe. And the nasty secret was the recipe was she would go to the fridge and figure out all the stuff that she had to clean out. She'd grind it all up and put it in a chili pot, and it was the best chili you ever had, right? But you could never mathematically calculate that. It was art, not science, right? Being a chef, to me, is art. It's just not something I could do. But you know what? If I could get the absolute procedures and the right tools and everything and put it all together in a very mechanical way, I could probably do this. And that's what happens in the manufacturing plants is we think it's art and not science. We have certain operators that know how to run certain pieces of equipment. We know certain things run better on certain days than others for certain customers. But we can't back it up with the data because we haven't started to interrogate and pull the data up. So we take this logical approach where we say, let's use these classical systems and I'm not picking on anybody, and I'm not picking on anybody's system, but the whole concept of MES and manufacturing execution systems, if you look to your left, that's what we think is going to happen. Get value right away, value goes up, cost comes down as I roll this thing out. When in fact, what we get is what's to the right. And this is everybody's MES. This is everybody's plant floor system. This is not about the technology specifically that you put in, but the process that you put in, which says, I'm going to make all of the rules and codify all of the rules, everything. I'll get all the experts together and decide how we make the best tomato sauce. I mean, jet engines or bicycles or whatever. And then we'll write those rules. And I love talking to the plant folks these days because when they do these evaluations, I always say, and you have to get it all today, right? Because those IT guys are never coming back. You're never going to get another bite of the apple. So they try to figure out everything they want to put in for the next 15 years because these systems and these operations tend to last 10 to 20 years, believe it or not. Right? When you go into a plant and you hear people talking about stuff that's that we should have replaced 10 years ago, that was like dead 10 years ago, right? But we're still running these. Who's got an iPhone? Tablet? Who has a tablet? Let me see your hands. We have tablets on our plant floors now that didn't exist 8 years ago in a consumable way, right? A $400 device you could buy in the store and put on the plant floor. So all those rules you wrote 15 years ago had zero consideration for tablets. What's going to be different in 5 or 8 years? What happens when the operator comes in and puts on their headgear and their glasses and everything's brought right up into their viewfinder as a heads-up display? I mean, that happens now. I'm not talking Star Wars. This is stuff that's available today if people want to start to adopt it. So we built these rules, and what happens is because those rules got frozen in cement, then the value starts to diminish over time and the cost swings back up because now I have to build all these sidecar systems, these other applications, right? So think about what we're talking about. The application for tomatoes in New England is applicable for rice in Japan. Because it's not about tomatoes in New England or rice in Japan. It's about how you start to go in and say, where can I probe and get data to start to release into the process so I can start to consume it so that I can start to make better decisions. So our approach is to say, rather than convince each other that we all know what all the questions are, because if you really get down to it, all the manufacturing folks know they don't know what all the questions are. If we start to think about, let me ask you another question. Who's got an iPhone 6? Raise your hand. Anybody want to ante up what was wrong with the iPhone 5 that you got rid of? Right? The other thing in plants is we always take this approach that says, well, I put it in, it's going to now last for 10 or 15 years. Because that's what we do. But I have a drawer full of iPhones and Trios and handsprings and all these other things that I get rid of, I swap them. Now you get the new iPhone, you put in your iCloud, password, user ID, provisions the thing. 15 minutes later, you're ready to roll. But we don't think about machines and devices, right? Because then we flip to the other side and we say, well, how do I get to the legacy devices? How do I get to this? How do I censor up this projector here? It's not built for that. And we miss the point that I don't necessarily need to get an excruciating amount of data from that. I can get pieces of data from that. I can take the temperature of the room. I could see that the lights are on, and I could pick up sound coming out of the system, and we could guess that there's a presentation going on. Right? Probably with a Raspberry Pi, probably for $40, probably by the end of this presentation if somebody was creative enough. What we tend to think when we IoT enable or IIoT enable a device is, how do I get to that projector? How do I get the temperature off the lamp? How do I get the fan speed? How do I get this? How do I get that? When in fact I could start to pick off pieces of data from elsewhere. So let's set that aside for a second. That's about figuring out how to go from art to science with respect to how we use the data. Has anybody seen this? So at Minds and Machines, Andy McAfee did this presentation. Anybody see this? So this is great. If you Google it, you can get it. It's the day 2 closing keynote. It's about halfway through. He did just an awesome job talking about it. And what they did is this study where they studied studies. And they said, how many times was the algorithm right, was the expert right, or was it a toss-up? And based on what they found is it was a toss-up. The algorithm was just as good as the expert 48% of the time. The algorithm was solely correct 46% of the time. So 6% of the time, the expert was the only one who knew the right answer. Let's go back to the example of the machine in the plant. This is the expert of experts, not the expert of my business in this plant for this process, right? I'm probably down to like a 2% or 0.5% chance of having the expert right, the science versus the art. So if I start to unlock data, if I start to pull the data up, if I start to consume this data, right, we're talking about get connected. So what we're talking about is how can we go into, and this is really part of what drove the strategy with PTC, is to say, let's go into the plants, let's start to hook to things, let's start to IIoT enable these machines in a way that most people haven't. Let's start to infer different pieces of data. Let's start to hook to different things so we can start this understanding around running some machine learning against it. So first connect to things, then draw some insight. And once I can draw some insight and run some math on it, then I can let the algorithm speak and say, here's the next best action to do. Because if you come from operations, you understand that sometimes the most profitable thing to do is to turn a machine on, and sometimes it's to turn a machine off. And many times it's not really clear which one is the most profitable for the network, not the node. We optimize a node. So we keep thinking about machines, we keep thinking about wildly complicated access to data from assets, when in fact I have plants that have 60-year-old hobbing machines that run really well, that have just no digital signals coming off them. So one of our engineers is talking about, hey, what if we took and put a Fitbit on the spindle of a machine tool that had an accelerometer, right? The same idea, put the Fitbit on you and it just gets a little bit of data and it learns from that data and it learns from patterns, right? What do we hear in the first section of the presentation is watch the patterns and start to understand how those patterns impact behavior, and then we start to get better at it. And then what we'll probably find is that there are some percentage of assets that we don't quite need anymore because the rest of them run that much better. We could start to flush some assets and bring the rest of the assets along. But we're getting out of the art and into the science by connecting up to the devices and by allowing the algorithm to process. So connect to the devices. And this year in 2016, and the speed with which you can do this time last year, we had a lot of discussion, but we didn't have a path forward on this process. This time last year. By mid-year, we'd already run our FastWorks experiment. So again, mash up a bunch of tomatoes, go into a plant, look at a cell, look at a line, look at a specific use case, turn it on very quickly, prove out what works, programatize it, and roll it out. This year, we're going to roll out probably 75 plants that give us visibility to the critical assets in the plant in a very consumable way based on the partnership that we're driving with PTC. The digital thread, this concept, anybody here a digital twin? So digital twin, digital thread is a matter of saying, how do I go from my design all the way through the make process, all the way back into the service process, and understand everything that happened to this device that's of any interest. Now, I don't know that this Logitech mouse clicker thing is that interesting, but if this were a blade in a turbine, where I wanted to understand the impact of creep on the performance of a turbine, where it's $1 million a day downtime or more, right? I can't just say when the blade got installed until now my service point. I really have to look at what machine was it cut on, what profile was cut, what heat of raw material, how was that processed. I might even be looking at how things are stored when I'm talking about these composites. The Airbus, the 787 is a single piece forward section with this carbon fiber tape. It's like wrapping tape around is one of the most awesome things you'll ever see. It's like one solid piece. And that material expires when it's removed from the refrigerator over a certain amount of time. Now we know this amount of time it's still good, but what window is really the window where we can optimize the cost and the performance of the asset, right? So you've got to be able to work all the way back through, and it becomes this self-improving system, right? Kind of self-healing system. It starts to provide more information. Think about the tools we have in the social media space. Think about Waze, social GPS. If you don't use it, look at the application and understand what happens when all you do is hand something to 1 million people and accumulate data about where they are and how fast they're going and how that overlays on a map and where they stopped along the way and did they stop at a Starbucks and did they check in and all of this data is just being consumed, algorithm and learning is being applied to it, and then we're starting to determine the best practice going forward. That doesn't happen inside plants because we just want to, for some reason, logically step back 20 years the minute we go into the plant. So the better together approach is to say, look, we've been in the marketplace for 20 years with our software tools. When I started with GE, I was a customer of GE's software tools for our plants. And we identified some gaps that were holding us up, that weren't allowing us to move as quickly as possible. We teamed up with PTC. That teaming up created such significant value so quickly, we said, look, we're going to embed this as part of our solutions going forward. This is what's being rolled out to the 75 plants. But it's really about creating a predictable model, right, that's repeatable, these small projects that go very fast that can be rolled out across the operations. And this is, you know, when you start to go to the science from the art piece of it, when you start to collect the data. So this little animation to your right is a process where you propel metal particles at supersonic speed against a part. So you have a gear that's worn down, and what you can do is you can print or rebuild that part and then recut it, because without going too deep in the engineering stuff that I mostly forget, right? When you heat things and you add metal to it, you actually break down the properties of the original part. Well, this doesn't transfer the heat into the part, right? So we call it spray coating or cold forming type process. It's kind of magical process, but it's really based completely in science. That's what our engineers and what our PhDs do. This engineer, Andy Henderson from Greenville, sent me this quote just offhand. He said, it's not really a brilliant factory, it's a serendipitous factory, right? It's actually this factory where solutions show up before you realize you had a problem. When you start to listen to the data, when you start to understand how that data impacts the network, not the node, not just the machine or the line, but the entire process, you can start to send information, you can start to pre-position parts, you can send skills, you can call up operators, you can bring people in, you could ask people to stay home based on how you're going to run that operation. So again, it's not about some wildly overcomplicated process of digitizing everything there is to digitize in this room. It's about knowing what to digitize, how quickly we can get that data, how quickly we can start to move it into, we're building this cloud for the industrial Internet of Things predicts, how quickly we can consume it there so that we can run those algorithms and bring that data back down and drive the process. And then, the sales guys like to say we drink our own champagne, the manufacturing folks say we eat our own dog food. We're eating our own dog food, right? We're going to roll this out to 75 factories and say, look, that's hardened for commercial use. Why wouldn't we push this into the marketplace and see who believes there's value in adopting and team up with those folks and say, okay, look, make it better, help us make it better, help us bring the right people into the discussion. So I wanted to share with you some of the things that we've been doing in GE in our own facilities, in our own plants, on our own machines, to drive a different type of discussion, a very practical discussion around the industrial Internet of Things and how you enable these machines. So I think we wanted to take one or two questions.
We have maybe 5 minutes. We can do some questions with quick answers.
Sure. That was a polite way of saying I ran over. Questions? All the way
One in the
back?
back, will you repeat it, please?
Sure.
You gave a couple of use cases, things with gain benefits, and it would mean that all the benefits were very high level and gain that was quantified.
So more specific. So on the digital thread side, so the question was around more specific use cases and benefits. So on the digital thread side, it's tying the 3D model into the manufacturing space, and we've been able to take 20% out of the time to move NPI, right? So in the FastWorks mode, you get the customer in. We say, look, instead of us assuming we know what you want and then getting it to you, why don't we work together up front? Why don't we push those into the NPI process quicker? And based on having the unencumbered digital flow of data, we get about 20% out of the NPI time on some big parts. 10 to 15% performance increase in critical assets in plants and bottleneck assets. And again, just like we're not trying to get every piece of data off one machine, we're not necessarily trying to sensor every machine. We're looking at the bottleneck machines, the critical machines in a process. And we did that in our transportation, and there's actually a couple different presentations from our transportation team, and they'll go into very, very specific detail. But how to process the parts quicker through bottlenecks because of machine data that flowed up. So that took about 10 points, I think, out of the, or added 10 points to the throughput. And then once we had that data, they can do conditional routing and say, instead of doing all 10 steps on this one asset, you can do 5 on this one and 10 on this one, 5 on the next. And they've taken cost out that way. So there's a couple examples. And we have more. If you want to talk, I'll give you a card. We can give you some more data. Another question?
Does PTC sort of have an assessment tool that you use when you go into a manufacturer that says, gosh, I'd like to turn my plant into an Internet of Things capable plant? You start with a baseline assessment of where they are. Do you have an implementation plan that you give to them? Start here. Next year you do this. Next year you do this. How do you do that?
So that's a good question. So your question is, do we have a prescribed kind of methodology where we can start a conversation and kind of have a recommendation? So yes and no. So if very often when we talk with manufacturers like GE, for example, some manufacturers already have a perspective where they want to improve some specific areas of their manufacturing operation, whether it's critical assets or maintenance or quality. So in that case, then with the flexibility we have with the solution, then we'll just dig directly into that use case. If then you're looking for a broader perspective, then we can also support this with a workshop environment where very often what we recommend is actually just train a couple of your people directly on the platform, start to discuss what are the different use cases that apply in your own manufacturing facility. And where the approach is very different is we recommend just to start building something. Let's start small, but let's do something real. If you have a machine, if you have a process that is critical, and if you already have people that have this idea, what if I could only combine this data with that data and that data? This is where the power of such a solution comes into fruition, in the sense that we can actually enable it in a couple of days. And with GE, just to finalize, with GE we've created or came up with I'd say a high-level prescriptive approach or recommended approach for the factory where it basically has 3 steps. So what we recommend is first, in order to improve your operations, you need to get access to the data. So you basically need to get connected to both the machines and your manufacturing systems. And even with the get connected step, as you'll see probably in some of the other GE presentation across the conference, you can gain very specific concrete benefits. Some of the factories are saying that just by connecting critical assets, by gaining visibility into which machine is running, which one isn't, and more importantly, why, then they were able to reduce unplanned downtime by 20%. So the get connected first step is actually not only a first step, it's a first step that has a lot of business value. And then from there, you can go into gaining additional insight, and then eventually go to the predictive model. That's kind of the high-level 3 steps approach. But if you already have if you have a specific problem you want to solve, what this approach is about, it's instead of trying to change the entire infrastructure and the entire architecture and replace a lot of things, let's just go and connect the different data sources you need in order to solve that specific
So
problem.
we have a playbook we built. We're rolling 75 plants, can't do it without a cookbook. No point in starting if you don't know what, why to that what, and what the baseline is to that what, because on the other end, somebody's going to say, you know, how much did you chip away at this 500 million, right? 1% gets us 500 million. So we just, it's our nature to programatize things and scale things out quickly. So we've laid that out literally end to end, the playbook.
Okay, thank you, Paul,
Thanks.
and thank you, JP. We're going to